Well, hello again. We are back. We are on our, I believe this is our fifth video covering the 1998 AP Calculus AB exam, Section 1, Part B. As you can see in blue, we do get to use a calculator for these problems. We will cover problems 83 through 92, all right? And don't forget to follow me so you get notifications every time I post new videos. Also, ring that bell, give me a like. That helps me out more than it helps you out. But you know, what is it? You literally move your hand like maybe an inch or two with the mouse, and you press your index finger down like not even a quarter of an inch, just a little click. Give me a like. I would like that. All right, let's start. 83 says, if a cannot equal 0, then the limit, the limit as a approaches x of x squared minus a squared over x to the fourth minus a to the fourth is. All right, there's two ways to do these. You can factor and you can cancel and then substitute in the a. Factoring never goes away. Or, okay, if I were to substitute an a in here right now, if I were to put this a right here and right there, I would end up with 0 over 0. That means we can use L'Hopital's rule. What is L'Hopital's rule? L'Hopital's rule is that I can take the derivative of the top and the derivative of the bottom separately. And the great part about this is as follows. The top, the derivative of the first term is 2x. This term is a constant. A is a constant. That the derivative of a constant is 0, goes away. So, the derivative of the bottom. Derivative of x to the fourth is 4x cubed. The derivative of a to the fourth, again, a is a constant. All right, a is a constant and it goes away. All right, so this is what I have. Now I can try and take the limit again. All right, you would get, all right, let's do this. I mean, I can cancel now. I can reduce my fraction now or plug the a in now. It doesn't matter. Let's just plug the a in now. I have 2a over 4a cubed. I put my a in for my x's. I can reduce. 1a goes away. I now have a squared. 2 goes into 4 twice. That leaves a 1 up here. So I have 1 over 2a squared. That's my answer. And that is choice A. I'm lying. It's choice B. Oh, I can't even have choice B. All right. We're good. Oh, I really don't like when they ask these population grows questions. That's more of an Algebra 2 question, but it's also a way for calculus for them to test you on separable differentiable equations. All right? 84 reads, population y grows according to the equation dy dt equals ky, where k is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is. All right. Well, let's just get right into this. All right, I need to take that. dy dt equals ky. I want to get my dy and y on the same side, and then I'm going to get my dt and k on the same side. Remember, k is a constant. We are using the variable t, but k is a constant. Like, think of it like the number 5. Okay? So the first thing I'm going to do is multiply both sides by 1 over y. These cancel. What I do to one side, I have to do to the other. Then I am going to multiply both sides by dt. These cancel, and I multiply this side by dt. So let's write everything we got right now, get all these colors into one monochromatic color scheme. 1y dy equals k dt. All right. At this point, I need to integrate both sides. I want to get rid of the dy and the dt, so I'm going to integrate both sides. All right. This simply gives me the n of y plus a constant. There are no bounds. I need to add a constant, okay? This here gives me kt plus c. Now keep in mind, if I'm integrating the number 5, let's call it dx, it would just give me 5x, right? So if you're confused on how I got this, I'm just going to explain it quick. Because if I take the derivative of 5x, I just get 5. But don't forget, integration works backwards. So instead of the x just going bye-bye, the x comes back when I integrate. All right? There we go. So I still want to get the y alone. Okay, so what I'm going to do is the following. I'm going to put a base e to both sides. How come? Before I do that, let's subtract a c from both sides. Resist the urge to cancel this one and to cancel this one, okay? Because these constants could be different constants. So I like to say this is constant 1 and constant 2, right? So I subtract constant 1 from both sides. This is still going to give you a constant on the right side. It could be 0. 0 is still a constant, but chances are it's not, okay? So now I have the L n of y equals kt plus c. All right, everything's doing good. Everything's doing good. And we will go green. Now I'm going to do a base e, because that is going to get my y alone. Y equals e to the kt plus c. Now, our rules for exponents tell us the only time we add exponents together is when we multiply like bases. Okay? So, what we multiply like bases, what I mean is x squared times x to the 5th, that is x to the 7th. I add my exponents. So what I'm going to do is I have this right now. I'm going to split it back up with my e. So I got e to the kt times e to the c. If I were to multiply those together for one base, I would add the exponents, wouldn't I? But I'm putting it back into the product of two bases. All right, e is a constant, c is a constant, which means this is really just a constant. So I've got y equals c times e to the kt. Oh my goodness. This is where we need to get a piece of information from our problem. The population doubles every 10 years. Okay, this is the end amount right here. This is the initial amount. I can pick any numbers that double. I can say my population started at 50, ended to be 100. I could say it started at 15 million, ended up being 30 million. Well, let's keep it simple. 1 and double 1 is 2. And it doubles every 10 years. Okay, let's just do that. That works, okay? So I now have 2 equals e to the 10k, all right? So we're asking to find k. We did a lot of work to set that up. But guess what I'm going to do? Guess what I'm going to do? All right? I can graph those, or I can take the ln of both sides and get an equation instead of a graph. Let's graph that. We haven't used the calculator yet. I could use natural log on both sides. You know what? That's probably what they would do. Take the natural log of this side, take the natural log of this side, and you have the natural log of 2 equals 10k, and I divide both sides by 10. So now I'm just putting this in the calculator. Okay, I'm just going to put this in the calculator, and that's going to equal my k. If I wanted to, what I had, oh, it's all together. What I had in blue here, I could have graphed in y1 and y2. I could have put 2 in y1, and I could have put e to the 10k in y2, and I could have saw where they intersected. But you know, it's good to do algebra. It's good to brush up on algebra. So this is a lot for a problem. It was 1998 people weren't messing around, huh? we have the ln of 2 divided by 10. 0.069, and that 9 will stay at 9 because the number after it is less than 5. So 0.069 is the approximation for K, and that's choice A. Is it A this time? It is A this time. Man, that was some work. But of course, I'm doing explanations as I go. That was a lot of work for a problem. 85. Okay, something a little bit more manageable. The function f is continuous at the closed interval from 2 to 8. Okay, here to here, actually here to here, from 2 to 8. Okay, and has values that are given in the table in the above. Use the subintervals 2, 5, 5, 7, and 7, 8. What is the trapezoidal approximation of the integral? So we're doing area under the curve, and we're using the trapezoidal rule. Now, the trapezoidal rule tells me that I need to, okay, that I need to take my width divided by 2, all right, and then I take all my values. The first value, which I'll just call value 1, and the last value, value n, are themselves. Everything in the middle gets doubled. Value 2, 2 times value whatever. Okay, the book ends, okay, the ones on the end don't double. Everything in the middle needs to double. But we're not going to have to double anything because it looks like they just give us book ends. What does that mean, Visca? Let me explain. Okay, so I got to go from 2 to 5. That's the first subinterval. The next subinterval goes from 5 to 7. And the last one goes from 7 to 8. Okay? This width has a width of 3. This width is a width of 2. And this width is a width of 1. Okay? So let's look at our first one right now. Okay? The width is 3. That goes over 2. I only have my book ends, 10 and 30. There's nothing in between them to double. Okay? That will give me the area under this red section. I got to add that to the area of the green section. I take my width of 2 over 2, and I just have book ends, 30 and 40. Okay? Then I add that to my blue area under the curve, which is a width of 1. I put that over 2. And the bookends are 40 and 20. The explanation is more work than the actual work. What do I mean? Well, now I have 3 over 2 times, that's 40. Okay, 2 goes into 40 20 times. 3 times 20 is 60. Plus, this is just 1. 70 plus 60, half of 60 is 30. 70 and 30 is 100. 100 plus 60, 160. Sorry about that 0. I got excited at the end there. Choice C. Number 86, the challenge here is the setup. Okay, we have the use of a calculator, so we are going to use that bad boy. Number 86 says, the base of a solid is a region in the first quadrant bounded by the x-axis, the y-axis, and the line x plus 2y equals 8. Okay, so this is our equation of a line. So let's do something here. X equals 2y plus 8. Oh yeah, I'll be okay. X plus 2y equals 8. Oh, man. Ooh. X plus 2y equals 8. Okay, let's subtract x from both sides. I'm just making this y equal. So I got 2y equals negative x plus 8. Divide everything by 2. So the equation of that line is negative 1/2 x plus 4. Okay, I just did my division here. This is the equation of our line. That's the equation of the line. That's going to come in handy. If the cross-section of the solid perpendicular to the x-axis are semicircles, okay, which means semicircle, semicircle, semicircle. They're solids, okay? Solids are semicircles. What is the volume of the solid? Okay, well, I need to integrate area to get volume, okay? So here's the issue. Okay, two things. One, the area of a circle, that means circle, not zero, is pi r squared, okay? Which means I need to square the radius. This formula is the full diameter, not the radius. So I need half of this to get the radius. So if my y equation is my diameter, then half of my y is my radius. And that's what I'm going to have to put right here. So it's pi times 1/2 negative 1/2 x plus 4. Okay, this is y, half of y. Okay? So I need to square that. Pi r squared. This is area. That's the area of a circle. Keep in mind, these are semicircles. If they're semicircles, I don't want the area of the whole circle. I want an area of half of my circle. So I want half of this area, which means what I do to one side, I have to do to the other, which means I'm going to have to multiply this whole thing by a half. Oh my goodness. That means I'm going to integrate this whole mess from 0 to 8. From 0 to 8. So let me write this nice and neat up here. We're going to integrate from 0 to 8. Okay? 1/2. Okay, I'm going to put my pi on the outside. Pi r squared. 1/2 of negative 1/2 x plus 4. Okay? This is the radius. Squared. Pi r squared. But also, I want half of that, because I don't want the whole circle, I want half the circle. So this half is for the radius, making the diameter into the radius. And this half is, I don't want the area of the entire circle, but half the circle, the semicircle. Whew, that setup was more than the actual work, because I have this calculator, and I'm going to use the poop out of it. I'm going to put that integral in my calculator and see what I come up with. Okay, I'm going to say 0.5 instead of 1/2. They are the same, you know. Math 9 is my integration from 0 to 8. Okay, and now I'm going to write this in here. It is parenthesis 0.5, another parenthesis. Okay, negative 0.5 x plus 4. I close my parenthesis for my y, and then I need to close the parenthesis to include that initial 1/2. It is important that when I square everything, I need to square the half as well, okay? This was just for my y. Remember, I need to take half of my y, and then I need to square the whole thing. So now I square it. Those parentheses are very, very important in this problem. And it's dx. I hit enter. Hopefully I come up with what I need. And it is 16.755. Okay, this 5 will stay a 5 because the number after it is less than 5. 16.755. Oh, choice C. A lot of work. Okay, number 87. Which of the following is an equation of a line tangent to the graph of f of x equals x to the fourth plus 2x squared at the point where f prime of x equals 1? Okay, first of all, immediately, equation of a line, y minus y1 equals m times x minus x1. Okay, normally, well, actually, all the time, we need 3 pieces of information. We need an x and a y, and we need a slope. Slope normally is, I should say usually, slope is usually the hardest thing to get, but they give that to you. The derivative is the slope. We don't have x1 and we don't have y1, okay? We need these two. That's strange, the way they ask us. Hey, 1998 was a weird year, man. Nirvana was on the scene. Things were going crazy. Grunge rock was everywhere. And Blink 182, my favorite all-time band, was 1 year away from releasing Enema of the State, their album. If you have not heard that album, you need to go buy it immediately. It has all the small things. What's My Age Again? Adam's song on there. Going Away to College. Wendy Clear. Anthem. I mean, there are Dysentery Gary. So many good songs in there. Blink 182, Enema of the State. Watch it. Anyways, let's go back here. All right, so how can I get an x value? Well, let me tell you. First of all, there's one thing I know. The derivative is 1 at whatever x point I have. That derivative is going to be 1. So let's take the derivative. We come up with 4x cubed plus 4x. All right? That's the derivative, and whatever x value I want, that should equal 1. That's what this is telling me here. So I can get my x value by setting this equal to 1 in the calculator. That's exactly what I'm going to do, because it's going to be something pretty fancy. By fancy, I just mean decimals. So we have y equals, oh, I got to put my marker down. Whoop! Y equals 4x, yep, not to the 6 cubed, plus 4x equal to 1. And I'm going to graph that puppy. And they're going to intersect somewhere at some random crazy decimal. Okay, and there's okay, second trace. I want my intersect function. Hit enter 3 times. Bang, bang, bang. And that happens, we'll call that at 0.237. Okay, 0.237. We really shouldn't round until the end. Okay, so that's at x equals 0.237. 0.237. Okay, I need to find y. Okay, I always go back to the original equation when I have an x to find a y. So f, I'm going to plug in my x, which is 0.237, into both of my x's. So it's x to the 4th plus 2x squared. And again, 0.237, 0.237. And in my calculator, you'll notice down here, it automatically stores into x that value. So when I hit x, that's my value. So I can literally put x to the 4th plus 2x squared. And in for x is that long decimal that we rounded to 0.237. 0.115. Let's call that 0.115. That's my y. Now it's just a matter of getting y alone. So I've got y minus 0.115 equals, if I distribute that, that's going to maintain the same thing. I'm just going to add 0.115. Okay? And it would be a shame. That's 2, 2, 1, negative 0.112. Okay, and that looks like, is that choice D? That looks like choice D, and it is. Right there. Everybody freaks out when your answers are like this, and you use this right here. I mean, literally, you're just taking this and bringing it over to this side. Okay, and just doing some basic algebra. Good. Gosh, 88. Yeah, I said gosh. These seem so much more difficult than they actually are if you just understand your basic integral rule. 88 reads, let capital F of x be the antiderivative of this right here. Okay, that means if I integrate this, I'm going to get capital F of x. All right, that's what this is telling you right here. If f of 1 is 0, then what's f of 9? A lot of people freak out, but let's not forget, when I integrate something and I have bounds, I always get my upper bound minus my lower bound. That's all it is. These are your bounds from lower bound 1 to upper bound 9. So from 1 to 9. I'm going to integrate this. ln of x cubed over x. Don't forget we need a dx. You will get points taken off. Well, this is multiple choice. But on short answers, if you don't write that dummy variable, you get points taken off. From my upper bound to my lower bound. I mean, that's literally it. And we have a calculator. Let's put this in the calculator. And oh, by the way, they tell us f of 1 is actually 0. So all I got to do is figure out, well, put that in the calculator and get a number here. And by the way, f of 9 minus 0 is just f of 9. So whatever this is, I didn't even need this arrow. I didn't even need more space. Whatever this is going to be my answer here. All right, I'm getting excited because that was really, this is an easy problem to do. Let's go math 9. We are going to go from 1 to 9, and now I'm actually going to use alpha y equals and get to, oh my god, there it is. And put in the ln, okay, parentheses, the ln of x. I got to cube the whole thing all over x. And my dummy variable is x. That should give us 5.82. This will round to a 7 because the number after it's bigger. 5.827. Okay? If this is 827, that means this is 5.827, which means my answer, a lot of C's. C, C. 89. If g is differentiable function such that g of x is less than 0 for all real numbers, a lot of people don't really pay attention to this because they always say things like it can't be 0 for all real numbers in the domain, whatever. But in this problem, this is going to come back and be really super helpful for us. It's going to be necessary, actually. Okay? If f prime, the derivative of f, is x squared minus 4 times g of x. Okay, that's times. Which of the following is true? First of all, in multiplication, if I'm always using a negative number here, this will always be negative. It will always flip the sign of whatever this is. Okay, I'm multiplying this times this. Okay, right now I have a negative number for g of x. Okay, so let's look at this. Put this on a number line, okay? X squared minus 4. Let's find our critical values. This is the first derivative. This happens when x is plus or minus 2. That's the only places where that's 0. So I'm going to go here. Here's the first derivative. Well, really, it's just this part of the first derivative, okay? It's not the whole first derivative. My x value at -2 and at +2 is 0. All right? Now, let's try some values in between here. Again, this is only x squared minus 4, so I'm going to write x squared minus 4 for the top. If I put a 0 in for x, I get -4, so it's negative. All right? If I put in a 3 for x, I get 9 minus 4, which is +5. And if I put a -3 in for x, guess what? -3 squared is still 9. 9 minus 4 is still +5. So that's what I have right here is a representation of just this. Keep in mind, I'm multiplying it times a negative. So I'm going to multiply all these by a negative, which means it's going to flip all these signs. This will turn negative, This will turn positive. This will be negative. Okay? So my slope goes down, my slope goes up, then my slope comes down. So we have a minimum here, and we have a maximum here. Okay? This is all the information we have on that first derivative that's given to us in the problem. So, which is true? F has a relative maximum at -2. No, at -2 it's a minimum. It's not a maximum, it's a minimum. F has a relative minimum at -2 and maximum at 2, right? Maximum at 2, minimum at -2. That looks like it's the correct answer. And it is. Boop, boop. There we go. Number 90. If the base B of a triangle is increasing at a rate of 3 inches per minute, while its height is decreasing at a rate of 3 inches per minute, which of the following must be true about the area of the triangle? It's either always increasing, decreasing, decreasing. Okay, we need to find dA, the change in rate of the triangle with respect to time. That's what this increasing, decreasing stuff means. The area of a triangle, okay, it's 1/2 base times height, all right? So dA, with respect to time, I'm going to leave this constant out, 1/2. Product rule, kids. First times the derivative of the second plus the second times the derivative of the first. This is a related rates problem. Every time we take the derivative of a variable, derivative of h is 1, we got to put dh. When we take the derivative of a variable, it's still 1, the derivative of b, but it's db. All right? So what do I know? All right, well, the base of triangle, the base is increasing. That's positive 3 inches. So dB is a positive 3 times h. Okay? And the height is decreasing. That's negative 3. Okay? So the height is negative 3 times b. And of course, this is all still times 1/2. So I've got 1/2 negative 3b and then a positive 3h. All right, that's what we got so far. So we got to take a look at this and figure out, okay, is A always increasing? No, because if this value is bigger than this value, I will have a bigger negative number, which means it would be decreasing, not increasing. Okay, same thing with B, it can't always be decreasing, because if my H is bigger than my B, then I will have a I'll have a bigger positive number. Bigative, bigger and positive, bigative. I'm patenting that word, don't use it. Okay, so C, A is decreasing when B is less than H. No, B has to be bigger than H for this to be a bigger negative value. So that's not true. A is decreasing. Okay, A is decreasing when your B is bigger. That is true. When this value is bigger than this value, that means this negative number will be a larger negative number, if that makes sense, than this positive number. It would absolutely be decreasing. Your answer is D. Woo! It doesn't remain constant all the time. That's horse poop. Poppycock horse poop. 91. Let f be a function that is differentiable in the open interval from 1 to 10. All right. If it is differentiable, it has to be continuous. That's a rule. If f of 2 is -5, and if f of 5 is 5, and f of 9 is -5, which of the following must be true? All right? I'm just going to sketch this out a little bit. Okay, here's 1, here's 10, okay? If f of 2 is -5, here's 2, here's -5. I'm plotting this point. Remember, this is a coordinate. X is 2, y is -5. When x is 5, y is 5. So here's 5, 5. So I'm plotting the next one. Okay, I should color coordinate these. Red, red. Blue, my x and y is blue. Green, when x is 9, y is -5. Okay, 9 would be right about here, boop, right here. So if it's differentiable, it's continuous. So it's, for some reason, it has to go through here, being continuous, it has to go through here. I don't know what it does, blah, 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 but it has to go through those points, has to. And it has to be a line that never breaks. It's continuous. If it's differentiable, it has to be continuous. The opposite isn't always true. Okay, just because it's continuous doesn't mean it's differentiable. But if it's differentiable, it's continuous. So let's take a look at this. Let's get some answers on the board here. Bing! All right, at least 2 zeros. That's true. It has to touch at least twice to go from here up to here and back down. You have to cross the x-axis at least twice. The graph of f has at least one horizontal tangent line. Yeah, in order to get from our starting point to our ending point, that's a horizontal line. That means at some place in between the endpoints, I have to have the same slope, a horizontal tangent line. The one I drew is right here. That is true. For some value c, f of c has got to be 3. If this, here's 3. There has to be a coordinate somewhere. In this case, 2 of them, that you got a y value of 3. That is also true. Guess what? They're all true. They are all true. 92, the last one. This is a longer video because there were 10 problems. If k is between 0 and pi over 2, and the area under the curve y equals cosine from x is k to x is pi over 2 is 0.1, then what is k? Nice problem to end with. Area under the curve is integration. Okay? K is the lower bound, because they said k is in between 0 and pi over 2. If pi over 2 is the upper bound, this has to be smaller. So from k to pi over 2, we're integrating this, cosine of x dx. And when I integrate it, I get 0.1. All right, what do I take the derivative of that gives me cosine? Sine of x. I want that from k to pi over 2, and that should equal 0.1. Let's plug in our upper bound, the sine of pi over 2, which is 90 degrees, minus the sine of k equals 0.1. Shame on you if you don't know this yet. Sine is the S curve. That should give you a value of 1. If you don't know, now you know. Sine goes up, down, up. Here's 90 degrees, or pi over 2. That happens at 1. Sine of 90 is 1. Okay? Minus the sine of k equals 0.1. Let's subtract 1 from both sides. Okay? Subtract 1, subtract 1. I've got negative sine of k equals negative 0.9. Okay, then let's just get rid of this minus sign. We'll multiply both sides by -1 or divide by -1. So I've got sine of k equals 0.9. How do we solve for k? We set it up like this. K equals the sine of -1 of 0.9, and we put that right in the calculator. Let's do this. Let's do this. Turn this on. There you go. Second, sine -1 of 0.9. 1.120. That 9, this will raise up to 20 because the number after it's bigger. 1.120. There you go, which is choice D. And we are fine. Thank you. Give me a like, ring that bell, and buy the Enema of the State album. It is worth it. I trust you. You will do it. It will change your life. Trust me. Bye-bye.